Hey everyone, so this next section is about the relationship between arcs and chords. So chords we learned about in the first section. A chord is a segment when the end points are on the circle. So that's a chord, and then arcs we've been talking about this last section. So there are some relationships when you have arcs and chords that share an end point. All right, let's get started. Okay, so first it says here, which I already just described, points on a circle determine both chords and arcs. So if you have an arc and a chord that have the same endpoints, we say that that arc is of that chord. So for example, do we see how arc RS right here and chord RS, they share these endpoints? So we would say that arc RS is the arc of chord RS. So they're not the same measure, which I explain in this little blurb right here. They're definitely not the same measure because here's why. This is a curve and it's usually measured in degrees, and then this is a straight line. So they're never the same measure. But there are some relationships that happen when you have an arc and a chord with the same endpoints. So let's take a look at the first one. So first of all, if you have two minor arcs that are congruent, their corresponding chords are congruent. So if we take a look at this picture here, notice how chord RS is congruent to chord ST is congruent to chord TU. Because those chords are congruent, that would mean that all of their corresponding arcs are congruent. So RS would be congruent to ST, that was supposed to be a curve, would be congruent to arc ST, would be congruent to TU. So all three of those arcs would be the same. So we can say that arc RS is congruent to arc ST, is congruent to arc TU. And again, that's because their chords are congruent. So if we're given that RS is 60, that would mean that they're all 60. So to answer this question, the measure of arc ST is 60 degrees, and the measure of arc TU is also 60. Okay, they're all 60 because the chords are congruent. Another theorem about arcs and chords is if you have a diameter or a radius, which remember this is a radius right here. A diameter would just be if it's all the way through. So same idea. If you have a diameter or a radius that is perpendicular to a chord. So see how this is a right angle. Remember, perpendicular means 90-degree angle. So if a radius is perpendicular to a chord, it cuts that chord in half. It also cuts the arc in half. So this arc AB is the arc of chord AB. So that's also cut in half. So that means that arc AC is equal to arc CB. Okay, so now let's use that in the given information to solve. So it says AB is 40, so this whole thing is 40. So that would mean that AD is 20 and DB is 20 because it's cut in half. Also, we were given that the measure of arc AC is 71. So we already determined that CB and AC are congruent, so that would mean CB is also 71. So I like to label the picture with everything I know, and then I go and answer the questions. So then it makes it easier. So letter A is asking for arc BC, which we already just found was 71 degrees. Letter B is asking for the measure of arc AB, which is this whole thing. So we're just gonna add 71 and 71 to get 142 degrees. And then we need segment AD, which we already found was 20 centimeters, and BD is also 20. Okay, so that's the second theorem about arcs and chords. We have one more theorem, and it has to do with chords that are equidistant to the center. That just means chords that are the same distance from the center. So if you take a look at this example 3, do we see how we have chord VW and chord ZY? Notice these little segments here, LU and UM. Those segments represent the distance from the chord to the center. Notice those are the same. They're both 8. So that means that the chords here, VW and ZY, are equidistant to the center. And so what happens if they're equidistant to the center is the chords themselves are congruent. So that would mean in this example that VW is congruent to ZY. And the reason for that is because LU is equal to UM. So if VW and ZY are equal, we can easily solve this. So they gave us that VW is 20, so this is 20, and ZY is 5x. We just determined that VW and ZY are equal. So for your equation, we're just going to set them equal to each other. So it's going to be 5x equals 20. Divide both sides by 5, and we get x is 4. Okay, so remember that if chords are congruent, their arcs are congruent. So for this example, let me zoom in on just this one. We're given that arc TR is congruent to arc TV. So let's think about what that means. If those are congruent, then that would mean their chords are congruent. So TR and TV would be the same, which would then lead us to conclude that SZ, we just learned this, and ZU are congruent. So these are equal and the chords are equal. It's kind of hard to mark that. The chords are congruent here. Okay, so if we have congruent arcs, we have congruent chords, we have congruent distances to the center. So let's look at what we're given here. It says SZ is x plus 4, so that's this little tiny piece here. It's going to be hard for me to label, but I'll try my best. And then UZ is 2x minus 1. So we just determined that SZ is congruent to UZ. Remember, because we were given the arcs are the same, and so the chords are the same. So the distance from the center is the same. So again, we're going to just set these equal to each other. X plus 4 equals 2x minus 1, and then solve for x. So I'm going to bring this x over to the right-hand side. So 2x minus x is x, and we have minus 1, and then we'll add 1 to both sides. So x is 5. Okay, so there's that one. I have a couple more examples to do with you guys. Here's another one. So for this one, we are given that the chords are the same. If the chords are the same, that would tell us these arcs are the same. So arc JK is congruent to arc KL. Notice KL is marked with X, so that would mean JK is X. Now, these arcs that we're given, all 3 of them, notice they make the full circle. And a full circle is 360 degrees. So what we're going to do is we're going to add all of the arcs, x plus 70, and it's equal to 360. There is a way that you can do this without writing an equation. You could just subtract 70 from 360 and then cut it in half, because that would be the 2 equal arcs. But if for some of you, if you prefer to write an equation, here's the equation. So 2x plus 70 equals 360. And then just solve for x. So we're going to subtract 70. So we have 2x equals 290, and then divide by 2. So we get x equals 145. Okay, so there's that one. And then the last one, we are given circle G. We're given some information in circle G that TG is 5, GU is 3, and we're also given TU is 4, so this is 4. We're also given TR, this segment here, is congruent to CA. So that means that the arcs are congruent. That would also mean that these pieces are congruent. One other thing that we're given here is this diameter is perpendicular to the chords, intersects the chords at right angles. So remember that that means it cuts the chords in half. it also, we don't need it in this particular example, but it also cuts the arcs in half. So this arc would be equal to this arc, which would be equal to this arc and equal to this arc. So we have a lot of things that are equal here. Okay, so let's fill in the missing information. Letter A, we need to find TR. So again, since this is cut in half, TR, this is 4, so this is 4, so the whole thing would be 8. So TR is just 8, 4 and 4. CD, CD is over here, which is marked as congruent to TU, which is 4. And then GD, GD is this little piece, which we determined is congruent to this little piece, so therefore it's 3. Okay, so that's our last example for this section. I have some practice for you to do. If you have any questions, please let us know. You can also join our Zoom session at 11:30. All right, guys, have a great day.